Hello, everyone. My presentation today will be about different approaches to classification of foods. One big point, we're really talking about classifying the relative healthfulness of foods. And this is why the various approaches are typically validated with respect to some measure of a healthy diet. So what are the two approaches? One is based on nutrient profiling. Full disclosure here, I'm one of the authors of an early nutrient profiling system. My publication on the healthfulness of foods towards a nutrient density score was published in 2004. Time passes quickly. So nutrient profiling, which became a whole area of research since, is based on nutrients and desirable food pattern equivalents calculated per 100 grams, per 100 calories, or per serving. The typical ways to balance positive and negative nutrients, I'll come to define those later on, and algorithms applied to nutrient composition databases give you various nutrient profiling systems. Among the ones you've read about are Nutri-Score, Health Star Rating, and my own Nutrient-Rich Food Index. And those have been used for front of pack labels, grades, logos, and so on. So this is a nutrient and food group based approach. On the other side, we have the NOVA classification, and that is strictly speaking based on the nature of and the intent behind industrial food processing. Carlos Montero, who developed the system again some time ago, was insistent it was really not about nutrients. It wasn't about fat, sugar, and salt. It was about something else, something specific to industrial processing. So here the foods are assigned into 4 food groups: minimally processed, processed, ultra-processed, and culinary ingredients. There's one problem with this classification. It is very subjective. How do you divine the nature and the intent behind industrial processing of foods? You've been hearing about the intent and the purpose of processing. Those are now components of the NOVA system. So here I actually like to talk not about the ultra-processed foods. I'd like to talk about foods which fall into the ultra-processed category as decided today by somebody. Key conceptual distinction: ultra-processed foods against foods that fall into the ultra-processed category based on somebody's decision. Whose? Now, 2 approaches have their own proponents. There was a report published a week ago by a number of European scientists saying that the European Commission must choose the Nutri-Score nutrient labeling system as the defining way of classifying foods into healthy and unhealthy. And some time ago, the Food and Agriculture Organization of the United Nations published a report supporting the ultra-processed foods classification. And since that time, I think the number of papers on ultra-processed foods and health outcomes has now reached 1,000 or so. So you have one approach, which is nutrient-based with its proponents, and the NOVA approach based on some formulation of food processing, which has got its own proponents. So let's start with nutrient profiling. Nutrient profiling can be based on negative elements or negative components only. Interestingly, calories are a negative component. It's bad to have too many calories. So is added sugar, saturated fat, and sodium. This actually leads to some amusing paradoxes because here nutrient density is conceptualized as the absence of calories, the absence of fat, the absence of sugar, and the absence of salt. I used to joke about 10 years ago, when you do that, you end up with a glass of water. I'm no longer laughing because in the last issue of the dietary guidelines, you have sparkling water identified as a nutrient-dense food. So that is actually from the dietary guidelines. What can I say? So is sparkling water a nutrient-dense food? I don't think so. This is now becoming a big issue in low and middle income countries where having some calories is not a crime and perhaps having some sodium is not so bad. And of course, with hidden hunger, having vitamins and minerals and high quality protein is essential. So here you have approached nutrient profiling, which is based on positive elements or nutrients, protein and fiber, vitamins and minerals, and increasingly desirable ingredients or desirable food pattern equivalents, if you want to use the technical term used by the USDA, and those include whole grains, fruits, vegetables, dairy, and healthy fats. And many nutrient profiling models, including my own, balance the two components, the positive and negative, and can be difference between means, difference between sums. You have a positive component and a negative component, and your final score is the difference between the two. So nutrient profiling, just to remind you, has been used in a number of ways. We start off with regulatory and educational, and nutrient profiling is the science behind nutrition and health claims in front of pack symbols and logos. And it also has been used to regulate marketing to children, and it has been used as the basis for taxes on frowned upon foods. Then you have the uses of nutrient profiling in dietary guidelines. But to my mind, what's really very important is that nutrient profiling has been used as the basis and benchmarking for reformulation of foods by the food industry. And you've been hearing about that, and you'll be hearing more about that later on. So in fact, I think that product reformulation by the food industry is the most significant application of nutrient profiling from the standpoint of public health, much more so than from the pack labels or shelf labels or any of those things. So those are a number of applications of nutrient profiling. And let's move on to a specific concrete example. What you have here on the left is the Nutrient-Rich Foods Index, which I developed some time ago. Come to think of it, it was 2008. And on the right, you have Nutri-Score point system, the one that must be used by the European Union to assess the healthfulness of foods. Notice commonalities. The Nutrient-Rich Food Index has 9 nutrients to encourage and 3 nutrients to limit. There are other versions of Nutrient-Rich Food Index. You don't need to go to 9 nutrients. You can do with 6 or 8 or 7. I'll show you examples. But those include typically protein and fiber and a number of vitamins and minerals. Here I have calcium, iron, potassium, magnesium, vitamin A, vitamin C, and vitamin E. In more recent versions, we have been using vitamin D instead of vitamin E. Back in 2008, data for vitamin D were not available. So to some extent, nutrient profiling is governed or bound by the type of databases that you have. If you don't have the data, you can't do any profiling. What you have on the right-hand side is the Nutri-Score point system. It's based on a set of thresholds. And here you have points accruing as calories go up, as saturated fat goes up, as total sugar goes up, and as sodium goes up. And then you get some positive points for protein and fiber, and also you get positive points for the food's content of vegetables and fruit by weight, which actually is impossible to calculate. So on the left, Nutrient-Rich Food Index, sum of percent daily values for the positive components minus the sum of percent daily values for the negative components. Higher score means it's good. On the right side, Nutri-Score, and here higher point means it's bad. Now, since Nutri-Score penalizes energy and saturated fat and total sugar, it pretty much penalizes energy density of foods. So in fact, Nutri-Score is a transform. It's almost collinear with energy density. That's all it is. So in fact, if you capture energy density, you might just be capturing energy density. Don't call it a Nutri-Score. It does not really capture any nutrients at all. So what you see on the left is a correlation between energy density and Nutri-Score points. And what you see on the right is, of course, inverse correlation between Nutri-Score and NRF. You know, they're inversely linked because Higher scores in Nutri-Score are bad, higher score in NRF are good. And notice that a number of foods here, which happen to be plant-based beverages, have the same exact Nutri-Score score, but vary a great deal on the NRF nutrient density score. And this is because the plant-based beverages are typically fortified with calcium, vitamin A, and vitamin D, which nutrient-rich food index does capture, but Nutri-Score absolutely does not. Nutri-Score captures energy density, and that's about it. So let's move on here. A couple more things. Many of those scores are, of course, correlated. What you see here on the left is the NRF 7.3 nutrient density score. I think I skipped out on magnesium and maybe vitamin D. And here you have Nutri-Score on the vertical axis. Green is good, yellow not so good, orange not so good, and red very bad. Again, notice the inverse correlation. And what you have on the right is Choices International, again plotted against the NRF 7.3. Nutri-Score, some of you may know this, is actually not a French score. It was originally based on the British FSA Ofcom nutrient density score developed by Mike Rayner. It kind of transmuted its way into France, and Choices International began its life as the Unilever score, which then became Choices International. So many of those scores are connected, they're all correlated. Some are better than others, and some capture nutrient density better than others. There's one amusing component, and that is for political reasons. Nutri-Score applies different scores to beverages and to solid foods. And in France, plant-based milk alternatives are to be treated, according to the French government, as solid foods, meaning they get a free pass because the criteria for added sugar are much more favorable for solids than they are for the beverages. In fact, for the beverages, the only good beverage in Nutri-Score is water. That's the only one that gets an A. Nothing else does. But when you treat plant-based milk alternatives as solids, they get a different score, and the score is much more favorable. So here you have Nutri-Score plotted against nutrient-rich, which does not change, and the Nutri-Score changes completely depending whether you treat the beverages as liquids or whether you treat them, as the French government demands, as solid foods. The policy does come into it, or politics come into it. So let's skip on to the next component of my presentation and ask some penetrating questions about what is NOVA categorization about really. So is it about energy density, fat, sugar, and salt? Carlos Monteiro famously said, absolutely not. It is not about fat, sugar, and salt. It is about other things. But when you start looking at the various definitions of highly processed foods, the ultra-processed foods, you see in small print, it does come back to energy-dense foods, high in calories, added sugar, saturated fat and salt, and low in dietary fiber, proteins, vitamins, and minerals. And so you say, well, the NOVA categorization seems to be the exact opposite of nutrient density, and the NOVA categorization will work in the opposite way to the nutrient-rich food index. And of course it does. So then you move to the next level of definition of NOVA, and you say, well, it's about additives, because foods falling into the ultra-processed category contain additives designed to make the final product more palatable, more appealing, and those include flavors and flavor enhancers and colors and emulsifiers and sweeteners and thickeners and so on, which are not found in normal cooking. So then you have this distinction between regular kitchen and industrial processing. And one of the interesting things about NOVA is that homemade bread is fine. Homemade yogurt is fine. Freshly squeezed orange juice is fine. The moment you buy the exact same products from industry, you're as good as that. So my question, of course, is exactly how many domestic staff does Carlos Monteiro have in Brazil? Because someone is squeezing that orange juice and probably isn't him. So the question then is, why are homemade foods given a pass and the same foods from industry or not. So then you start looking and you say, well, is it really all about industrial processing? And yes, you find that because some definitions say those are industrial formulations of various foods which contain very little real food. Those are created foods from components with flavorings, emulsifiers, and so on in bright packaging. And then you get into this issue of hyperpalatability and quasi-addictive properties of food. So then you say, well, after you've read all of those papers, and again, remember, those definitions change with time, and one paper and another paper are not necessarily the same. You say, what is it all about really? So then there are 2 points that ought to be made, and some of them have been made already. There's a critical distinction to be made between formulation engineering and processing engineering. There's nothing wrong with processing. The addition of fat and sugar and salt and additives and chemicals is really the result of formulation and not processing per se. And then paradoxically, the plant-based milk alternatives have undergone a whole range of processes, including grinding, drying, powdering, high pressure electric fields, and so on. And that is not what makes them ultra processed. What makes them ultra processed is the addition of a little guar gum. That makes it ultra processed. So judging the extent and the purpose of industrial processing can be very difficult, and many people have come across those problems. So I was actually entertained reading a paper in Nature Food a while back, published by a very, very prominent group of researchers, one of the very best, who in the appendix to the paper published the NOVA classifications of close to 8,000 foods in the USDA FNDDS database. In a fairly user-unfriendly way, they published this as a 100-page PDF. But PDFs can be transformed into Excel by smart undergraduate students in a matter of minutes. And then I looked at that and got a shock because everything was ultra-processed. Boiled carrots, ultra-processed. Green beans, ultra-processed. Everything is ultra-processed. So in fact, out of the 8,000 foods in FNDDS, 77% were classified as ultra-processed, which seemed rather a lot. And in fact, only 339 foods out of 8,000 were classified as minimally processed. So you see on the right, all the various food groups, and red shows ultra-processed, which means practically everything was ultra-processed with very few exceptions, and no one seemed to have paid the slightest attention to that. So let me move on here and say that, remember, those foods classified as ultra-processed were actually linked to higher risk of obesity, diabetes, metabolic syndrome, and we are seeing here that pretty much everything was ultra-processed. Couple more points. The authors, to give them credit, published a correction saying that their machine learning algorithm led to incorrect NOVA classification for several items. And they say the reason, the way they're doing it now is doing it manually with the personal assistance of Professor Carlos Montero. So to decide that, that's actually published in Nature Food. So if you want to classify foods as ultra-processed, all you need to do is to make a call to Brazil. So to close, there are those two systems, and there's a conflict between them. In fact, a French group keeps writing papers how Nutri-Score and ultra-processing are two dimensions, complementary, non-contradictory. Another paper with the same title. If you have to write papers saying that there is no conflict, believe me, there is a conflict. And so the problem is that many of the foods which are falling into the ultra-processed category also get 5 stars on Health Star rating, or they get a score on Nutri-Score. So what to do about that? So one of the proposals, since withdrawn, has been to have the A on Nutri-Score encircled by a black band to show that the food was healthy, but not as healthy as all that. So my thought also, I don't have a slide for that, was to have black clouds among the 5 stars, again, to show that you have nutrient-rich foods, but at the same time, they're ultra-processed. So, and this is just to show you the final slide, that in fact, foods getting A grade, Nutri-Score, 5 stars and health star ratings are for the most part foods falling into the ultra-processed category. And yes, there is a conflict given that one system and the other system are supposed to be final definitions of what is healthy and what is not healthy in the food supply. So let me finish here, and we'll get to the discussion about what exactly is it that has linked ultra-processed foods with adverse health outcomes, because 1,000 papers cannot be wrong. There are some answers to that, and we can talk about those later on. Thank you.
Thank you, Adam. I think we'll hold questions until a little bit later. Okay, so our next speaker is Dr. Rachel Bleiweiss-Sandy. Dr. Bleiweiss-Sandy is currently a human service researcher at Mathematica. She has published on the topic of processing levels to include comparison of categorization schemes, so we'll hear a lot more from her, and processing levels, particularly in the summer food service program meals. We welcome Dr. Bleiweiss-Sandy to share her insights into this conversation.
Great job pronouncing my name. I know it's a tough one, so I appreciate it. So my name is Rachel Bleiweiss-Sandy. I'm currently a researcher at Mathematica, which is a social policy research firm. And I work mostly for federal clients like FNS, but actually my dissertation research was completely devoted to this topic of processing. And I distinctly remember when my advisor promised me that I would never return to my dissertation research ever again in my career. But here we are, and I'm actually very happy to be here. This is a great topic that I love speaking about. So thank you all for having me. So the paper I've been asked to talk about today was part of my dissertation that I wrote while I was at the Friedman School of Nutrition Science and Policy. And some of the other presenters have touched on this fact that there's really no one universally accepted processing classification system. NOVA is certainly the system that dominates, but there have been others that have been used in research. And when I was doing my dissertation research, we wanted to ask this question of like, how do all these systems compare? And more specifically, if we took 100 random foods and we coded them using each of these different systems, would these foods line up? Would there be good inter-rater reliability between the systems? Which is to say, would 2 different coders code the same food in the same way using, the classifications that were laid out by each system? And finally, would conclusions about the association between processing level and healthfulness be the same if you looked at 3 different systems? And my research was specifically focused on the relationship between processing level and healthfulness among low-income children in the US. So I wanted to look at systems that had been applied to the dietary quality of Americans or folks living in the US. And at the time that I was looking at the literature, which was around 2017, there were 3 systems that were being used to examine processing level and diet quality in the US. I think we're all pretty familiar with the NOVA system. It was developed by researchers in Brazil, but then it was really widely adopted for use in research globally, including the US. And there were a few different versions of the NOVA system, as Dr. Dronowski mentioned. The one that seemed to appear most often in the literature had these 4 levels. I've also seen this system mentioned by Dr. Montero, and it had 3 levels, but we'll just go for 4 here. So this system started with minimally processed, and then it went up to ultra-processed foods. There were 2 other systems that I could find at the time that were developed specifically for use in the US. The first was put out by the International Food Information Council, or IFIC. It was used in a few articles to look at the nutrient quality of foods by processing category. The system also starts with minimally processed foods, but then it has totally different categories to that of NOVA. So it has these foods processed for preservation, mixtures of combined ingredients, ready-to-eat process, and then prepared foods meals. So you can see that these are just 2 very different systems here. And then there was a system developed by researchers at the University of North Carolina at Chapel Hill, or UNC. And this system classified all barcoded foods that are commonly sold in US supermarkets by processing level. The authors of the system described it as one that was guided by the NOVA system, but it was modified to capture the complexity of the US food supply with these enhanced category definitions and examples. And when you look at the NOVA and the UNC system side by side, you can see that they align pretty closely. There's just clearly more categories in the UNC system. So unlike the NOVA and the IFIC systems, which presented their definitions just as like a table and a paper with a few examples, the UNC system was published as this 40-page appendix. And this is just a little screenshot from that appendix. And the appendix contained an exhaustive list of every type of product that could be purchased in a US supermarket, and the processing level that would be assigned to each product. So the system was very specific and very well defined. This is what the IFIC system looked like. NOVA was very similar. They were presented as tables and papers, and there would be these definitions of each of the categories, and then some examples of each of those categories. So just to keep in mind. So going from that, we developed a couple objectives that we wanted to explore with these processing frameworks. The first was to look at inter-rater reliability, kind of as a measure of robustness. We hypothesized that inter-rater reliability would be highest for the UNC system because, as I mentioned, there was this comprehensive list of products and their processing categories, and we thought that would really reduce subjectivity when you're actually going through and trying to code many foods. Next, we wanted to look at agreement between the systems, and we hypothesized that the NOVA and UNC systems would have the highest agreement, given that the UNC system was based off of NOVA. And lastly, we wanted to look at the ability of nutrient concentrations of foods that were commonly consumed by children in the US to predict their assigned processing category for each system. And based on what we'd seen in the literature, we hypothesized that overconsumed nutrients, which we've been hearing about, added sugars, salt, saturated fats, would be better predictors of this ultra-processed or the highest processing category for the NOVA system. And I know it might sound a little strange to frame this question as how well a nutrient can predict a processing level, but what I was reading in the literature about NOVA suggested that this system was really developed to discourage added sugar and saturated fat in what they refer to as ultra-processed foods. So we hypothesized that the highly processed foods that were categorized by the NOVA system would be really well aligned with these overconsumed nutrients. And since I was specifically interested in looking at the types of foods that children in the US were eating, we used dietary recalls from children that participated in NHANES, and we compiled a list of all the foods that they were commonly consuming. Then we sorted that list and we chose the top 100 most commonly consumed foods by children in America, and we used those foods in our analysis. And we had two coders go through and they ranked all of the foods by processing level for each system, for the UNC system, the IFIC system, and the NOVA system. And we used that to assess inter-rater reliability. To answer this question about the relationship between processing classification systems and healthfulness, we looked to the nutrients of concern as defined by the 2015 Dietary Guidelines for Americans. And based on this, the 2015 guidelines, Americans were not reaching the daily recommended value for this set of underconsumed nutrients. It's kind of the usual suspects, potassium, magnesium, etc., vitamins A, C, E, D, and of course fiber. Americans never eat enough fiber. And they were eating more than the recommended daily allowance for saturated fat, sodium, and added sugar. So these were the nutrients that we were going to focus on in our analysis. And down here at the bottom, I just have the equation that we use to look at how well the proportion of underconsumed nutrients and overconsumed nutrients were able to predict the processing level for each system. I also wanted to quickly point out that we had two coders code the top 100 foods for each system using the system in their original forms. But as I mentioned, each system had different numbers of levels. So what we ended up doing was collapsing each system into 3 levels: unprocessed, moderately processed, and highly processed. And that allowed us to compare the 3 systems on the same scale. So to jump into the results, we found, as hypothesized, the UNC system had the highest inter-rater reliability. It was significantly higher than that of NOVA or IFIC, and I think this makes sense given the 40-page appendix that they had. It was very easy to go through and code foods using this system. It was also really interesting to look at what coders commonly disagreed on. We found it was really unclear using the NOVA and the IFIC system how to classify condiments, breads, and flavored milks. There's just a lot of subjectivity there. So coders would classify the foods in different ways. And I thought it might be sort of useful to go through a coding example using a very simple example: unflavored, unsalted peanut butter. This is a single ingredient food. It's just peanuts. So if you coded this using the IFIC system, unsalted peanut butter would fall into level 1, or minimally processed food. And I'm very confident in this classification because IFIC actually uses unsalted peanut butter as one of their examples of a minimally processed food. So we felt confident in that. NOVA classifies the peanut butter as level 2, or a processed culinary ingredient, similar to UNC. But as I mentioned, we then collapsed the levels into 3 basic categories after all of the systems, so that we could compare these systems in analysis. So we ended up kind of losing some nuance there. So all 3 systems would end up classifying this peanut butter as a level 1 food after we'd collapsed the categories. So as hypothesized, we found that the NOVA and the UNC systems had the highest agreement. That made sense. And I was actually pretty surprised at how well the IFIC and the UNC systems matched up. But again, this was likely more to do with having to collapse the systems for comparability. And so that nuance was lost, and the systems ended up looking a little more kind of comparable than they actually are. So I'm going to get a little bit into the weeds here with this linear discriminant analysis that we did. This looked at how well nutrient concentrations of the top 100 foods predicted their assigned processing category for each system. So if you look at the plots, each data point is a food. The red dots are minimally processed foods, the green dots are moderately processed foods, and the blue dots represent highly processed foods. So I won't do a sort of a deep examination of these plots, but I think the major point to take away here is that the nutrient concentrations of foods were really not successful in distinguishing between minimally, moderately, and highly processed foods. If they were, what we would see is no overlap between the ovals. They would be very spread out. We do see some spread in the red oval versus the blue oval. So minimally versus moderately processed foods had different levels of nutrient concentrations. So there was better predictability there. But there's almost 100% overlap in the green category, the moderately processed foods. So what we can tell there is that nutrient concentration is just really not the best predictor of processing category. We also ran a series of logistic regression models, and this looked at how well different nutrients discriminated between processing levels for each system. And again, I just wanted to point out a few takeaways here. So this table we're looking at is comparing moderately processed to minimally processed foods for each of these nutrients of concern. And what we see here is that higher sodium was predictive of moderate compared to less processed foods for all 3 systems. This was likely due to cheeses, which were commonly classified as moderately processed, and they tend to be higher in sodium. Higher added sugars was also a significant predictor of moderately compared to less processed foods, but just for the UNC system. And this was likely due to UNC assigning flavored yogurts and sweetened teas as moderately processed. And those are foods that tend to be very high in added sugars. Next, now we're just looking at highly processed compared to less processed levels. And again, added sugars were very strong predictors for all three systems. So higher sugar predicted a higher processing level. Higher sodium was also a significant predictor for all three systems, likely due to salty snacks like chips, pizza, and French fries that were classified as highly processed. So I think overall what we're seeing here are these consistent associations between overconsumed nutrients and higher processing level, and not very many associations between underconsumed nutrients and processing level. So a few big takeaways. We did find that the UNC system had the highest inter-rater reliability, and this suggests that having a comprehensive list of foods by processing category helps to reduce subjectivity. For the particular sample of foods used in this study, overconsumed nutrients were much better aligned with processing level, while underconsumed nutrients were really not predictive of processing category. And I think this just suggests that processing frameworks really lack specificity for underconsumed nutrients. They're just not useful in that regard. And of course, one of the major takeaways is that we need a standard system if we're going to continue to talk about processing level. Without the standard system, researchers that are using different systems can't compare their research. And given the low inter-rater reliability we found for systems like NOVA, I kind of question whether we can even compare different studies that have used the NOVA system. It would really be hard, given our kind of data on inter-rater reliability, to say with a lot of confidence that different coders are coding foods in the same way using the NOVA system across studies. And I think this really brings up the issue of how we should think about the usefulness of processing level in giving guidance to those people that we think could really benefit from guidance around healthfulness, low-income children and parents. So in the last few minutes of this presentation, I wanted to quickly mention some qualitative research that we did on consumer perceptions of processing level and how those aligned with researcher classification systems. At the time I was doing this research, there was not much written about how consumers in the US conceptualize processing. There may be more at this time, but back then there was just not much written on this topic. So we explored this in two qualitative studies, one focused on how low-income children thought about processing, and one on how parents from the same communities conceptualize this idea of processing. We decided to kind of use focus groups to ask these questions. And to get at an understanding of processing, we first set out some cards with these phrases one by one, and we asked participants to ask what they thought about these words. The first three were meant to give the group kind of a lexicon to talk about processing. So fresh foods, man-made foods, machine-made foods, they were just kind of like everyday phrases that we thought they could use to then talk about processed foods. And then we showed them 6 pictures. These are foods that fall into 3 different processing categories: minimally, moderately, and highly processed foods, according to these researcher systems. And we asked participants to tell us which processing category they would assign to the foods. And then finally, we asked them to talk a bit about healthfulness. So I've just grabbed a few of my favorite quotes from these focus groups. There's tons of data from these focus group studies, and it was really fun. When we asked kids about unprocessed foods, they had remarkably kind of on-target definitions. They said they were natural foods, things like a strawberry, nothing's changed. That was an easy one for them. We were surprised to see that parents had some different definitions of unprocessed foods. They talked about things that weren't ready to eat, they might not be good for health, they couldn't be digested. Some parents kind of understood the definition, but there was a good amount of distribution. In terms of processed foods, kids were often very literal. They said things like things that have gone through a big factory, and then they wanted to draw a picture of a factory, but they were kind of on target with what the NOVA system might classify as a processed food. More chemicals, more guar gum, etc. Parents would say things like, these are convenient foods. These are things that I can quickly give to my kids. These are packaged foods. They're frozen foods, things in a can. And there's this sort of sense of shame and guilt that actually came up when parents talked about processed foods, like, oh yeah, that's the frozen stuff that I feed to my kids because I don't have time to make things from scratch. I'm sorry that these images are covering there, but when we showed the pictures of the foods and we asked kids which one was processed, they were again very literal. They would say things like, well, I see a can, so clearly something happened there. That one's processed. And then parents really thought about processing in terms of healthfulness. They said things like the juice is highly processed, it's the most sugar, it's not healthy. So I think just to sum up here, participants clearly had some knowledge about processing, and I think this could be leveraged in communications about foods. But their understanding was clearly not consistent with the classification systems and research. And we really need to think about how we want to reconcile the terms used in research with what consumers are thinking about foods. I just have 1 minute left, so I'll quickly just mention that IFIC has developed some really great messaging around processing that highlights the positive aspects of processing: food safety, affordability, reduction of waste, convenience. And this runs completely counter to the messaging that we see coming from the NOVA system. This is an image from the dietary guidelines from the Brazilian population, which adopted the NOVA system. And their main message is really around the avoidance of these ultra-processed foods and just using minimally processed foods as much as possible. So I think this is really the most important kind of next step of the processing puzzle, figuring out what the most appropriate messages are for consumers, particularly low-income consumers and families. And I will end it there. Thank you.
Thank you, Rachel. Thanks for both the quantitative and the qualitative work. It's always really interesting to share what consumers are thinking in this space too. So we will move on to our third presenter within this section. And so we welcome Nadia Flexner of the University of Toronto. Nadia is a senior PhD student in the laboratory of Dr. Mary LeBay, where she focuses on estimating the dietary and health impact of various food policies. Nadia will be sharing some of her work on the application of these various food classification systems to that of the Canadian food supply. Nadia?
Well, thank you so much for the introduction. Let's see if this works. Oh, yes, it's working. Well, so, okay, I'll start my presentation. Thank you very much for the opportunity to present our work in this space. So this is my disclosure of conflict of interest. I'm just going to move here. Okay. So briefly, I'll start with some background. In Canada, 88% of all deaths are due to non-communicable diseases, and 63% of adults are affected by either obesity or overweight. 30% of Canadians are currently living with diabetes or pre-diabetes, and 23% of adults in Canada have hypertension. As we know, it has been well established that unhealthy diets are one of the major preventable risk factors for a range of NCDs. So Canadians' intakes of nutrients of public health concern are above recommended levels, as you can see in this picture, for saturated fats, sodium, total sugars, and sugars. And it has been estimated that ultra-processed products contribute to almost half of total daily energy intake, and that the main source of free sugars intakes among Canadians are ultra-processed products, which contribute to around 72%. So the government of Canada has taken a number of actions to improve the Canadian food environment. In 2016, Health Canada launched the Healthy Eating strategy with a vision to make the healthier choice the easier choice for all Canadians. And as part of this strategy, recommendations such as a revised Canada's food guide and implemented front-of-pack labeling were included. In 2019, Health Canada released the new Canada's Food Guide, or CFG, that emphasizes the importance of healthy food choices to improve overall health, switching from serving sizes recommendations to a more dietary pattern approach. So CFG recommends consuming plenty of vegetables and fruits, whole grain fruits, protein foods from different sources, may water your drink of choice, and to limit highly processed foods, among other recommendations. So Health Canada published front-of-pack labeling regulations in 2022 that will require foods and beverages that meet or exceed set thresholds for sodium, sugars, or saturated fat to display a high nutrition symbol on the front of the package. Some exemptions have been also included. For example, foods will be exempted from front-of-pack labeling regulations if they do not require to display a nutrition fact table, if they provide a protective effect on health, such as milk, eggs, fruits, and vegetables, and also for foods where the high nutrition symbol will be redundant, such as honey, salt, and syrup. So our front-of-pack labeling regulations support the Canada's Food Guide recommendation to limit highly processed foods that contribute to excess sodium, sugar, and saturated fat intake. So with this, Canada joins the group of 10 countries, mostly in the Americas region, that have adopted a mandatory high-in or excess-in front-of-pack labeling approach. And I'll just touch a little bit on nutrient profiling, which is the science of classifying or ranking foods according to their nutritional composition. It allows comparison between foods when some nutrient levels are higher and others are lower. It categorizes foods as opposed to diets, but can be used to improve the nutritional quality of diets. So nutrient profiling underpins many policies and regulations and has been widely used worldwide as a health promotion and NCD tool. Okay, so I'll briefly describe the NOVA classification criteria that we've been talking in the last two presentations. So NOVA 1, well, first of all, NOVA food classification system categorizes foods into 4 groups by nature, extent, and purpose of industrial food processing. That's the definition. NOVA 1 or minimally processed foods are edible parts of plants and animals after separation from nature or preserved by minimal industrial processes. And NOVA 2 are processed culinary ingredients, mainly oils, fats, sugars, honey, or salt. NOVA 3 or processed foods are foods in Group 1 and NOVA Group 1 that were industrially modified with the addition of salt, sugar, oils, or fats. And NOVA 4 or ultra-processed foods are formulations of ingredients mostly of exclusive industrial use that result from a series of industrial processes. That's the definition. And contain cosmetic additives and are usually high in nutrients of concern such as sodium, sugars, and fats. So in recent years, NOVA has been included in national dietary guidelines as a framework for dietary recommendations, starting in Brazil in 2014 and more recently in Chile and Mexico. Okay, so the University of Toronto Food Label Information Program includes nutritional information for almost 120,000 foods collected from the main supermarkets in Canada. Each product in Flip is assigned an ID number, and we capture different variables such as product name, nutritional information, list of ingredients, barcode, front-of-pack label elements, among others. So as part of Flip, we developed an app to collect the data inside of stores that has been used in Canada in 2013, 2017, and in Latin American Caribbean countries in 2018 and 2022. So the latest data collection in Canada was conducted through web scraping, and we use OCR technology. Once data is collected, it is processed following various steps to have it ready for different investigations, such as calculation of free sugars, level of processing, nutrient-profiling calculations, content of critical nutrients, identification of marketing techniques in the packaging, among other investigations. So now I'll present some results of our work on monitoring the Canadian food supply. I'll focus on the NOVA food classification system for this presentation since this is the topic, but first, just to start, we classify food products in Flip collection 2017 and 2020, following the steps detailed here. Validations were conducted among trained nutrition researchers, and a final third validation was conducted on both databases by a senior researcher. So, moving to some results, these are the proportion of foods categorized under NOVA 1, 2, 3, and 4. We found that 72% of products, packaged products, were classified as NOVA 4 or ultra-processed foods, and in 2017, and in 2020, the proportion went to 67. So we categorize products in FLIP into 24 major food categories and 172 minor food categories defined in Health Canada's Table of Reference Amounts for Food, or TRA in advance. So this graphic displays the distribution of products in each TRA food category by their NOVA classification. Ultra-processed or NOVA 4 are shown as a proportion in red, and minimally processed foods, or NOVA 1, are shown in green. As you can see, there is an important presence of ultra-processed foods among most TRA categories. So food categories highlighted here have a presence of 70% or more of ultra-processed foods according to NOVA, such as bakery products, combination dishes, desserts, meats and substitutes, sauces, snacks, soups, and sugar and sweets. While food categories such as cereals and other grains, eggs and substitutes, legumes, and nuts and seeds have more prevalence of unprocessed or minimally processed foods. So FLIP database were also examined for their overall nutritional quality using the Food Standard Australia and New Zealand nutrient profiling model. This nutrient profile model assigns a numerical score to foods based on presence of nutrients to limit and encourage. So the final score designates the food as healthy or less healthy, and lower scores indicate more healthy products. This figure shows a scatter plot of Fazan's score by NOVA category. We found moderate correlation between NOVA and Fazan's overall. So until here, I've presented an overall overview, but what about examining at the minor food category level? I think that it's important. How about in food categories recommended by the Canadian Food Guide, such as whole grains? Let's see an example. So products were considered for this analysis whole grain when the term whole grain, or the names of grains that are whole grain, was included as the first ingredient. Whole grain products were identified in 3 grain-related TRA categories, so bakery products, cereal and grain products, and combination dishes. These categories were chosen as they include most of the whole grains products accounting for Canadians' whole grain intake, and products without ingredient lists were excluded from this analysis. A total of 6,260 products in the 3 TRA categories were analyzed. We identified that 1,054 whole grain products, representing 17% of the total grain-related TRA categories. And from these, 29% were ready-to-eat breakfast cereals, and the second most prevalent were grain-based bars without filling. So this figure shows the proportion of whole grains products relative to non-whole grains in each subcategory for bakery products and for cereals as well. So we can see how whole grains dominate ready-to-eat breakfast cereal subcategories here in this slide. We then apply the Fazan score to measure the balance of positive to negative nutrients in whole grains, and Fazan score below 4 indicates healthy products. So overall, almost 50% of whole grain products will be considered less healthy according to Fazan. However, the lower Fazan's median compared to non-whole grain indicates whole grains have better nutritional quality compared to non-whole grain products. However, when we zoom into these food categories, the results varied. So whole grain bakery products were significantly healthier than their non-whole grain counterparts, but it was surprising that whole grain were less healthy than non-whole grains in the cereal category. The box plot for cereal also reveals high variability in healthiness score for whole grains. And within cereal products, ready-to-eat breakfast cereals scored the highest on Fazan's and therefore were the unhealthiest among the all subcategories in cereals, while breads had the healthiest score in bakery products. So let's see how we did under NOVA with whole grains. So under NOVA food classification criteria, 70% of whole grain products were classified as ultra-processed or NOVA 4, and for non-whole grains, this proportion was 76%. Again, looking at the subcategory, we see the processing levels differs by food category. Okay, and comparing whole grain products between NOVA and Fazan's, we found moderate correlation. So finding that most whole grain products are ultra-processed or less healthy, according to Fazan's, is not in alignment with the messaging of the Canadian Food Guide to both limit highly processed foods and eat whole grain foods. So the Canadian Food Guide recommends using food labels and ingredient lists to choose foods that have less sodium, sugar, or saturated fats, but it is still difficult for consumers to interpret nutrition information. So, this is the question. How should public health guidance and policies balance the need for increased whole grain consumption as well as decreased consumption of that are high in sodium, saturated fat, and sugar? One way could be by providing consumers with clear and easy to understand nutritional information on packaged foods that allow them to identify foods high in critical nutrients, but also compare between similar products and make healthier choices, such as our recently published farm fat labeling regulations. We hope that that will help consumers. So we apply the food classification criteria of the Canadian front of pack labeling regulations to our food database. And the first three bars here in this graphic shows products that will display 1, 2, or 3 high in front of pack labeling symbols according to Canadian regulations. And you can see that most of these products will be ultra-processed foods. If we look by nutrient of concern, most products will be ultra-processed food. However, there is still a proportion of products that will not display a high in symbol. And this is most likely because they don't meet or exceed the set threshold for displaying a front of pack label symbol, or because these were exempted foods that contribute to other positive nutrients such as calcium in cheese and yogurt. Before that, so we also examined how Canadian packaged foods will perform under food classification systems that are similar to the high in front of pack labeling approach approved in Canada. So for instance, Mexico and Argentina recently approved front of pack labeling regulations that consider NOVA as a base to classify foods that will be subject of the regulations. These countries use the Pan American Health Organization nutrient profile model, which is the first food classification criteria to focus on capturing ultra-processed foods, and is also based on WHO population nutrient intake goals to prevent obesity and diet-related NCDs. So this food classification criteria has been designed for multiple applications, such as front of pack labeling, regulations of marketing, and fiscal policies. The PAHO nutrient profile model defines when products are high in sugar, fats, saturated fats, trans fats, and sodium. So we compare how similar front of pack labeling approaches will capture ultra-processed foods. For this, we apply the PAHO nutrient profile model and the Chilean nutrient profile model to our food database. I should just note that Chile was the first country to implement a high in front of pack labeling symbol in 2016, and initial evaluations are showing promising results from this policy. So when comparing among these food classification systems, as expected, the PAHO nutrient profile model will capture most ultra-processed foods, while the Chilean and Canadian criteria will leave 19 and 34 of ultra-processed foods not regulated. These results are considering all parameters in each nutrient profile model. So Canada targets products high in saturated fat, sugar, and sodium. The Chile also target those nutrients, but also calories. And the PAHO nutrient profile model captures fats, saturated fat, trans fats, sugar, and sodium. So we all know that classification of foods is a labor-intensive and time-consuming task. Is there a way that we can accelerate this process? So we use natural language processing to predict NOVA food classification using our manually validate data from FLIP 2017. We excluded for this analysis products with no ingredient list. And we use FLIP Canada 2020 as a validation data set to validate the machine learning algorithms developed from FLIP Canada 2017. We then apply the algorithm to the prediction data sets from our database in FLIP Latin America, 2018 and 2022 for Argentina, and to the USDA branded food products database. These here are preliminary results. So we tested different machine learning algorithms that I'm not showing here, and most of them reach moderate to high accuracy in food NOVA classification. But it was the fine-tuned language model performed the best among different machine learning algorithms. And specifically, the fine-tuned language model reached an accuracy of 0.98 for unprocessed or minimally processed foods, 0.94 for processed culinary ingredients, 0.92 for processed foods, and 0.99 for ultra-processed foods. We applied this algorithm, the fine-tuned language model, to FLIP Canada 2020, the FLIP LAC database in Argentina, and the USDA branded food product database. The fine-tuned language model also performed moderately well when applied to randomly selected foods from Argentina and foods from the USDA branded food product database, and reached F1 scores of 0.89 and 0.95. We think that we theorize that the difference between Argentina and the U.S. is because the translation of in the ingredient list. Okay, just to finalize to wrap up my presentation, we found that most packaged foods in Canada will be classified as ultra-processed foods. In our whole grain examination, we found that most whole grain products available in the Canadian food supply are either categorized as ultra-processed or less healthy from using different nutrient profile models, which is not in alignment with recommendations to both limit highly processed foods and eat whole grains. However, this varies by food category, and it is important to provide clear and easy to interpret nutritional information so consumers can identify those healthy alternatives within each food category. On the other hand, front of pack labeling can help consumers to identify those products high in nutrients to limit, which are mostly ultra-processed foods. Lastly, the use of machine learning approaches has the potential to accelerate the process of food classification in a fairly accurate manner to help researchers and policymakers to timely monitor changes in the food supply and inform future policy decisions aiming to improve the food environment. With that, I would like to thank my supervisor, Dr. Mary Lave, and as well as my fellow lab members. So thank you for your attention and happy to take any questions.